yeah, that's all from the announcements. And now let's welcome our first speaker, Joel Drapper, that will tell us about that Ruby always has a types, had the types. And Joel himself enjoys metaprogramming, and he likes to go into those dark places that usually don't explore, and he's really passionate about that. And also he's creator of Flex and QuickDraw. Thank you.
Thank you. This is going to be pretty intense. Hopefully we can cover all the material, but thank you for having me. It's great to be here. This is my first ever Fratslav RB. Is that okay? I practiced that like 100 times and I still can't do it. So I'm here to tell you, well, actually, let me just introduce myself. If you don't know me, my name is Joel Drapper. I created the Vue component library, Flex. You find me on Blue Sky. I also blog at joel.drapper.me. I also co-host the Rooftop Ruby podcast. And you can find me on GitHub. I do a lot of like open source stuff. So I want to convince you that Ruby has literally always had types. And you might have some very strong opinions about types in Ruby. I know Rubyists, we hate types. This is the other title I was considering for this talk. Write less code, have fewer bugs. Because ultimately, like, that's the goal of everything that we're trying to do here. But let's go with this, because I want to convince you of this. Oh shit, my talks are broken. Oh no, that's part of my talk. So that's like actually genuinely really triggering whenever I see that. How many times have you seen this in production? Like, never? I want to tell you a quick story about this piece of code right here. This isn't the exact code, it was a long time ago, but this captures it. This code is extremely, extremely dangerous. Can anyone tell me why? Nope. That's not SQL, but that's a very, very good guess. Let's focus on this. So, yes, you got it. When you interpolate a string like this, what you're really doing is this. And so if you got a method missing error in production, you're the lucky one, right? Because at least it stopped. But nil responds to 2s. And so let's look at this code again. We take an email address. We delete tickets. We get the tickets by querying for email is this. So our query is going to be this if we have a null email address. And so when we send this to Zendesk, what are they going to do? They've basically got logically, there's two things that they could do. They could give us no tickets, or they could give us all tickets. And of course, they gave us all the tickets. So this code, combined with a bug in Rails, a bug in Puma, that was triggered by some weird race condition, turned into a CVE in both of those. This basically caused us to delete, I think it was like maybe 4,000 to 10,000 Zendesk tickets at Shopify before we managed to stop it. And it's all because we didn't have types, or at least that's what I'm going to try and convince you, right? So types are meant to fix this, right? And you're Rubyist, so you probably have a very strong opinion on this. Probably most of you hate the idea of types. Some of you might have tried TypeScript and maybe you even like it. I happen to be one of those degenerates who loves TypeScript. I think it's great. And there have been a few attempts to introduce static type checking into Ruby. Sorbet, notably, has probably gone the furthest. And this is where you kind of annotate using pseudo Ruby code that doesn't really execute, and then they have a compiler or like a static analysis tool that analyzes your code. There's also RBS, which is the official type annotation language, and you can either do that in separate files or you can do it in inline comments next to all your methods. But RBS doesn't have a type checker, so the best one out there right now is Steep by Satoru Matsumoto. And like, I applaud the effort that everyone has put into these tools, but I'm not entirely convinced that Ruby is comfortable being typed like this. I'm going to take a quick break. So, what are the issues with trying to statically type Ruby? Limited ability to catch issues. So, when you statically type check something, you kind of need to know what all of the types are in the entire system. So, you basically need to either be able to infer the types, or you need to actually have all of the types annotated to be able to track it through the code. And Ruby, like, there's just so much Ruby code out there that isn't already statically typed. I just don't think that the community is going to fully get behind, like, writing type annotations for everything. I just don't think that's going to happen. So introducing one of these tools into your code base is a significant upfront effort. I know that they've done a great job at Shopify, and I think, is it Stripe that uses this as well? There's probably a few other big companies that have done well from using Sorbet. I just don't think, like, the teams of like 10 people working on a reasonably large Rails app are ever going to be able to, reasonably tackle this job of like putting static types into their system. It's not compatible with metaprogramming, or at least it's very difficult to make it compatible. And yeah, you have to write about twice as much code. And I don't know if this is true or not. Obviously, like, this is like, it's always, the answer is always it depends. But some people say that bugs are a function of code, right? So the more lines of code you have, the more likely that there are bugs. It doesn't really matter what kind of code you're writing, whether it's type checkers. More code equals more surface area for bugs to appear. So let's kind of take a step back and think about, like, what really is a type? What does that even mean? And then think about, like, how are they useful, and how can we find some kind of like 80-20 principle where, like, is there a way that we can get the most out of types without doing the least amount of work? So my definition for a type is very abstract, and maybe this is not technically correct, but I don't think models need to be technically correct to be useful. My definition of a type is that it is a description of a set of objects. So it is not a set of objects, because you can have infinite types, and you couldn't possibly have an actual set of infinite objects. But it is just a description of one. And working with a description of a set of objects, you can determine, for some sets, some of them are impossible to calculate, but for many sets you can determine whether a given object fits inside that set. Like, if this set did exist, would this object exist inside it? Would this object be in that set? And if we think about this kind of, like, on the basis of this definition, when we look at Ruby, I think that Ruby has an interface that really captures this idea. And it's the triple equals, or case equality interface. In the context of Ruby, I think we can say that any object that responds to triple equals is a type. Let's look at a few examples. So here we have a couple of examples of classes. So with a class, you send triple equals, you pass it an object, and it will tell you if the object is an instance of that class or an instance of a subclass of that class. So this holds up to that standard. What about modules? Well, modules kind of work the same way. They will tell you if the object is either extends the module or is a instance of a class that includes the module. What about ranges? So ranges basically map this to their cover method. So the range will tell you if an object is covered by the range. What about regular expressions? They will check if the object matches the expression. What about procs? So procs map the triple equals method to the call method, which means that you can actually use a proc to define any arbitrary predicate type, right? A proc that takes an object, one parameter, returns truthy or falsy value. I would say, by my definition, that it is a type, or at least it can be treated as a type. And then objects themselves, so strings, let's go back. Strings, they triple equal to other strings that are equal in value to them. Most other objects, either triple equals means equal in value or the same object. The default implementation on object and on your own classes, if you haven't overridden it, will be that triple equals is same object. And actually, that means that we can treat these like objects by default are what we would call unit types. They're types of exactly one thing. Only one thing matches that type, and nothing else does. And you've actually already used these types. So when you write a case statement, you're not checking that the object is equal to the class integer, right? You're going to pass an integer. And so what Ruby is doing is it's going to send triple equals to integer. And if that is true, it's going to put I'm an integer. And if it's false, it's going to move on and check the next one. So you're already using types. Ruby, we just didn't name these types. I think they're named, I don't know what they're named in the Ruby source code, but also enumerable any, right? You probably know that you can pass a block to enumerable any, but did you know you can pass a type? Uses this interface. Same with all, you pass a type, it calls triple equals on the type with the object. Case statements with pattern matching. In fact, any pattern matching is based on this as well. So in this, it's kind of a bit of an obscure example, but it's going to use the triple equals method on array, string, to figure out like what this is. Now, with this in mind, that we can actually think about a type as just being an object, that means that we can create types, right? We can create objects that their only purpose is really to represent some type. Their purpose is to describe a set of objects. So here's an example of a type, calling it array type, that takes a parameter type, and it will check that when you ask if something matches that description, it will check that it's an array and that all of its values match the type that it's parameterized by. So if we do this, we can make a new type. So I can say I've got an array of strings, or I've got an array of integers, and then we can use the triple equals on that object to make assertions about our objects. And we can define a shortcut for this, right? We can define the method. I like to use underscore and then the name of the class if it's related to a class. The reason the underscore is here is because there's already a capital A letter array method in Ruby, and so this kind of disambiguates, but it's also quite nice because when you're, like, it looks kind of weird at first, but you get used to it, and then when you press underscore, Ruby LSP like predicts all of your types, which is kind of useful. So this means that we can create this array of strings type just by using underscore array string, and that also works with the triple equals interface. I should have given a false example here. So let me introduce my library literal. Literal is kind of, it's got a bunch of different tools, but you have to understand like how literal understands types, first of all, to be already this thing that exists in Ruby, this like first class thing. And then it just introduces a bunch of these kind of generics, like I showed you with the array. So I'll just run through some of these really quickly. Union, this is the OR type. So this is going to say this type represents either a string or a symbol. Intersection, this is the AND type. So this is going to be string and matches the regular expression of being a digit, or one or more digits. In fact, you can pass to union and to intersection. You can pass as many subtypes as you want as parameters. Constraint is like intersection in terms of its positional arguments, but then it also takes keyword arguments. And what it will do is it will call the keyword argument on the object, and then it will take the return value and compare it to the type that you passed in as the value to that keyword argument. So here, we've composed a type that says it must be a string, it must also be made up entirely of digits, and its length, the length of the string must be between 3 and 255. And we've done that in one line of code, barely any characters. There's actually we implement underscore string to essentially be a composition of this, of a constraint that is already set to be a constraint of a string, and then just pass everything through. I think you see that later on. There's also a type interface. So if you really want to do duck typing, you can depend on interfaces. So you can say, I don't care what kind of object it is, I just want to know that it responds to length and push. So this might be like a buffer or something. So array user, we already saw this one. This is in literal. Tuple is a bit like an array, except this is saying this is an array of exactly 2 items. The first item is an integer, and the second item is a string. Hash takes key and value types. So this is saying this is a hash where the key is a symbol and the value is a string for all of the instances. This is a bit of a more tricky example. The type we're looking at here is the type called deferred, but I had to do this big example to show you why you would even need it. So this is a type that represents JSON data. So JSON data can be, a union of nil, false, true, string, integer, float, or an array of JSON data. And since we haven't yet defined JSON data, using deferred, which takes a block, is a way that we can actually create these infinitely recursive types that reference themselves. So this is I believe, accurate type for infinitely nested JSON data, because hashes in JSON have a string as the key, but then they can have any data as their value. But we have that one, so you don't need to define it yourself. It's just underscore JSON data. So let me take a drink. Okay, we're okay on time. So why are types useful? I can't remember what my next slide is. Yeah, so types help us to make basically invalid states in our code impossible. If we're using types at runtime, we're not going to be able to kind of know statically that there are no impossible states in our code. But we can know that it's very difficult for our code to get into impossible states. Like, before it gets there, it's going to stop. So maybe you're going to get an exception in production. I talked about how you're the lucky one if you got a no method error in production, because actually, if you don't get an error, it's much worse. Like, something can actually happen. It can be silently deleting thousands and thousands and thousands of emails, and you don't know why. So 2 other tools that Literal provides are literal struct and literal data. And we'll look at data first. So these work in a very similar way to the struct and data objects that you get built into Ruby, except they take props. So you just subclass literal data or literal struct, depending on whether you want mutable or immutable value objects, and you define each property using this prop macro. So the first argument is the name of the property, and then the second argument is the type. And this can be any of the types we talked about, any composition of any type, anything that responds to triple equals. You could throw a proc in here, literally anything you want. In this case, we've actually made coordinates that cannot be invalid because we've constrained our latitude and longitude to floats, and they're even constrained to specific values of floats. In fact, what I would do is break this down even further and name those types. So latitude being a float of -90 to 90, let's give that a name, let's set it as a constant, and then just use that in our property. So if there's something else that references just one of these properties and needs to check it, like I don't know why you would have a job or whatever that takes just the longitude, but you could reference coordinates longitude as a type somewhere else. I just find that like naming these things can really help. Let's just look at some other things that this interface provides you. So by default, we use keyword arguments, but you can pass a third value, which is a symbol of positional, if you want a positional argument, or a star. My syntax highlighting is wrong, but I promise this is valid Ruby. A star if you want to soak up a splat, and that's going to have to be some kind of array type or it's going to error. Default keyword arguments, star star if you want a hash, if you want the a keyword splat, or ampersand if you want to define the block argument. You can also pass a default, which makes these properties optional. You don't have to pass them in. The default has to be a frozen object, or you have to pass it wrapped inside a proc. And the reason is in case you say like default and you put in an array or an array literal, and then every single instance of this is using the same array literal, and now you've got like a nasty bug. So we don't let you do that. You have to wrap it in a proc. If you do want to reference the same unfrozen thing, that's fine. Just wrap that reference in a proc. Point to a constant. Otherwise, these are optional if you explicitly use a type that is nillable. Now, I've used the nillable type constructor here to make a type that is essentially a union of nil and string. But you could use any type where its triple equals with nil passed to it returns truthy. And this is kind of intentionally ugly, the nillable thing, because using nillable types is something that you want to avoid mostly. Like sometimes you have to do it, but at least it kind of like stands out to be, at least that part is like kind of really ugly. One thing you can do, you can define the method string question mark and point it to nillable string if you want. That looks really pretty, but I almost don't want to make nillable stuff look pretty. So, okay, so let's run through the rest of this. You can also, using the keyword arguments reader and writer, you can set them to public, private, protected, or false if you don't want the readers and the writers. I switched to struct here instead of data because you can't have a writer on a data object. That's not a valid thing. So literal structs, literal data objects, by default, they both have readers, and by default, structs have writers as well. Let me just turn this on so I can keep track of my time. So you can also pass a block, and that block will be yielded the argument so that it can basically coerce that argument into your type. So say you want to call 2s on something that you want to require to be a string. You could do it like this, or you could even do it in the nice clean way with proc to proc. Sorry, symbol to proc. So literal properties. That's like good for value objects. Properties let you bring this interface into other classes. So let's say you want to inherit, you need to inherit from FlexHTML, you want to have properties, you can just extend literal properties, and then you get to do the same thing. So this is my button component. I'm defining size to be a union of small, medium, large, variant, union of primary, secondary, and then just setting up my props. And you'll notice also, I've used the prop class, because this is an HTML component. I want to pass in a CSS class. But class is a reserved keyword. So how does this work? The code that it generates will actually knows about reserved keywords, and it will use binding.localVariableGet in this case in the initializer that it generates for you. And then you can just reference it as @class, and that's always valid. So you don't have to worry about, I've seen people like take star options and then grab the class out of that, or like various hacks, or like class names. I don't like that stuff, so we just support it. There's also this other tool, literal enums, and these are constant enumerations. So there's like a few kinds of things that you can describe and like name. One is like when you make a class, you're kind of saying, like a regular class, you're kind of saying that there can be almost like infinite instances of this thing. With a constant enumeration, you might want to have an instance, but you just want to have like a limited number of instances. So a good example is like status, okay? So I have like a post status or something, and maybe I'm saving this to the database and I'm precious about my database storage, so I want to store like tiny little integers. So I'm gonna make this mapping from a constant name, which is gonna be an instance of the status class, to an integer. And that's actually constrained by the fact that we're inheriting from literal enum with integer in parentheses. So it's going to make sure that those are always integers. And what this gets you is like you're defining the constant, like status draft, status pending review, status published. And they are instances of the status class. So you can define methods in there. They have some default methods. So if I grab like status draft and ask it for its value, I get back 0. I can also send it predicates. I can ask it, is it draft, is it published? And it won't raise, it will return true or false, just based on the names. And I can also coerce either the value or the name as a symbol. And there's a bunch of other things in literal enum that you can do. Like you can actually have properties on your enums, which is useful for like, I don't know, a list of countries or something. You want to store the name, the key, the code, whatever. And you can define methods on the class or even on instances of the class by passing a block and then defining methods. I don't have an example. So with this status class, remember that we can use coercions by passing them as a block. So the status enum actually responds to toproc, and it will basically use its coerce method. So you can make interfaces like this post. When you create a new one, you can pass in a symbol published, and it will actually resolve via the coercion ampersand status into status published, the constant instance. And actually, these classes, just going back, the class and the instances are always frozen, so they can never change once you created them. Finally, values and decorators. So you could, like sometimes you end up creating a data object that just has one value in it, like it's an email address or user ID or something like that. And for that, there's like an easier way to do it. You can kind of do it on one line. I'm just creating like user ID here. Capital U is a class, and I can create new instances of it, and it just wraps the string. What's nice about this is you could actually define your user ID as this literal value, put in whatever your validation is there, and then once you have one, you know that it's safe, you know that it's frozen. And you can always get its value back out. You can also define it like this, and you can say, I want to delegate this set of methods to the underlying object. And that's useful because it means that you can kind of constrain the interface. You're not saying like every single method that's available on string should be available on user ID. You can like specify exactly what you want to share. If you do want to just decorate, there's also literal decorator, which you can use in the same way. And this will just essentially use method missing to just pass everything down. Speaking of method missing, let's talk about performance. It's a question I often get about this. It's like, are we doing loads of extra work? Is this going to be slow? It's not very slow. So because we use code generation, we're not doing like much at runtime. So when you use the prop methods, you're actually defining the initializer with code generation. So it's essentially as if you had written it yourself. It's just doing type checking and raising errors if there's something wrong. All of the types that literal have do essentially zero runtime allocations. It's possible that to generate a new inline cache, they will sometimes allocate. I think the types that call a method on the object being passed in will allocate if you call them with one thing and then you call them with a different kind of thing. I think there's like an inline cache that gets created, but generally they don't do any runtime allocations. The types are also highly optimized. So to give an example of this, let's look at the union type. So the union type is usually used maybe something like this. In this case, it's usually just a small set of things. If what it's going to do is it's going to call triple equals on string with the value. And if that returns true, it's going to early come out because it knows like it's or, it doesn't need to check symbol or array. If it's false, it will need to check all of the types. But let's say that you created a union of primitives. So things like strings, integers, I can't remember the full list, symbols definitely. So it turns out that primitives triple equals is equivalent to their hash equality, right? Because they're essentially value-based unit types. So when you create a union of primitives, or if there are primitives in there, the primitives will get put into a set. So you could have a union of like 1 million possible tags that are just simple primitives, strings, or whatever. And then you could check in O1 time. It would be incredibly fast. It wouldn't make any difference. The other thing is types are flattened when possible. So this example of, we've got like 3 unions, and then we put all 3 unions into another union. D isn't actually going to be a union of 3 unions. It's going to be a union of 9 primitives, because it's going to automatically be like, okay, I'm going to try and flatten this. And these also all happen, like typically all of these types are being allocated at boot time. So they happen once, you use the same thing again and again. It's frozen. If you do eager loading, it's going to be copy on write shared between all of your processes. So they're not going to take up much memory either. So what's next in literal? Collection objects. So let's look at an example. We've got a group that has members, and we're checking that when you pass in members, it's an array of users. But we want to add this method to add a new member. So what happens here is we check that when we get the array at the object boundary, it's definitely an array of users. But then we're able to add random things, like we could call add member with an integer, and it would be fine. It wouldn't complain. So you could obviously like do your own little check. This is a short one that you can do. The error messages from these are not very nice. But this, again, because pattern matching uses triple equals, we'll call triple equals on user and check. And that works. But I don't think that group should be responsible for this. I actually think that that's the array itself should be responsible. Just like looking at this from a kind of runtime perspective. And so we're going to build, or we're in the process of building a literal array type that is parameterized. So you could create literal arrays as objects. You create them with the type and with the values, and they ensure that you can't push incorrect values into them. Does that make sense so far? Okay. So collection objects. We're going to we're partway through building array, and actually partway into tuple, but not very far. We're going to build hash and set as well. And these will basically work like their counterparts in Ruby. Mostly every method, the reason they're taking so long is like these objects just have so many methods, and like implementing them in a way where you can't corrupt the types is quite a challenge. That gets us on to, let's take a quick detour. So I think tomorrow Stephen's going to talk about this idea of like an accordion of complexity, which is like building interfaces that kind of flex and scale with you and like with your use case and how far you want to go. So I just want to show like an example of this. So if you have this group, takes property of members, the simplest thing, you can just say that this should be an array, right? I don't need to think about generics. I don't need to think about anything else. This is going to give me a lot of safety, right? It's going to tell me it's not nil, it's not string, it's an array. The next layer is like, I want to check that it's an array of users at initialization. And then like another layer is then, I also want to make sure that you can't push invalid things into it. And the next layer would be like, it doesn't make sense to have a group of 1 person or 0 people. So let's make sure that the members must be 2 or more. And next layer up is like, let's actually create, like let's name that concept of group members so that it can be referenced in other places, or at least so that we know what it means. Getting back to collections, let's talk about variants for a second. So let's imagine we have a class fruit, and we also have these 3 classes that subclass fruit: apple, banana, orange. This is the simplest example I can come up with. We make a basket of fruit. We pass in a bunch of fruit, and we make a basket of apples. And then we want to concat these together, right? So in the first example, we have our basket of apples, and we want to shove into it our basket of fruit. That is invalid. In the second example, we have a basket of fruit, and we want to concat into it a basket of apples. That is valid. That shouldn't error. But we don't want to have to check every time, every time I shove my basket of apples into my basket of fruit. We want to basically take a shortcut. If we can compare the types apple and fruit to each other, we won't have to check all of the items. So the other thing that we're doing right now is, in order to support these collection objects, is make it so that you can compare these types to each other. And actually, like, you can compare all sorts of things. Like, you can say, like, it knows that the class proc is a subtype of the interface type call, right? Because the interface type call knows, in order to determine if I am a supertype of a class, I need to look at that class's instance methods. So there's all sorts of ways that we can like take shortcuts and have better performance when working with these things. And ultimately it means that doing one quick operation, just comparing the types themselves rather than the items, we can know that a certain kind of concatenation or operation on an array is safe. The other thing that we're adding is cross-property validation. So this is the idea that you can stipulate, you can make stipulations about like multiple properties kind of working together. So sometimes the validness of one attribute is actually determined by another attribute. And so the way that we're thinking of doing this is still kind of open to suggestions, is that you can make these stipulations and you pass a block, and we just look at what you've named the parameters on that block, and then we generate the code that's able to pass the correct attribute into those blocks. So the ordering doesn't matter, it's just that you have named the parameters correctly, and that they match up with the names of the properties. So here, like, we want to know that the name is between the lengths, we want to know that the min is less than max, we can do that. And finally, result objects. I'm not going to go into detail on this, but just the idea of having a result monad in literal. I know there's like dry monads and stuff, but I think that we can do a better job of integrating that with literal's type system. So I'm going to look into doing that. Another idea we had was that actually literal should be able to generate LLM schemas. LLM schemas are basically a way of telling LLMs, like, this is a kind of shape of an object that I want you to generate. And so, like, I don't know, I'm looking for recipes, they look like this. Can you go to this website and find me recipes? And then it will do it, and it will give you back JSON that matches that schema. And we should be able to generate these and then validate these as well. So let's just kind of look back over what we've learned. Ruby has types, and most Ruby objects are types. I think that, like, we might disagree on whether that's true or not, but whatever I'm calling types, it definitely does have, right? And you're definitely using them. We looked at literal types, we looked at literal struct and data, which are mutable and immutable data objects. We looked at literal properties that let you bring the same interface into your own objects. Enums let you have constant enumerations of objects, and value and decorators let you wrap a single value like a user ID. And the advantage there, I probably should have talked about this, is that you can make an interface that says, I need a user ID. Like, I don't want any string. You need to give me a user ID. For me, having used this for a number of years now, it feels like the sort of Goldilocks solution, right? Complete type safety in Ruby just, for me, has been unattainable, and I've tried a bunch of different tools. But also, just being like fully dynamic, everything's fine, don't check anything. At the end of the day, you have to check stuff. And so it's a case of like, am I checking stuff by writing loads of code out manually, or by using this, like composing these beautiful types together in ways that I can like give them nice names and pass them around and call them. For me, I much prefer to write less code. So the benefits for me are less typing, like literally. I don't have to type as much on my keyboard. This concept of a property has been named. So what was before maybe like 6 different things. Let's see, you've got your initializer that takes parameters. It assigns instance variables. It checks that they're valid. Then maybe you've got an attr reader separately in a different part of the code. And then maybe you've overridden the attr writer to check something or to coerce something. And that code has to stay in sync with your initializer. You can end up writing a lot of code to try to do this. But having this concept of a property as being like this one thing, for me, it just really simplifies that idea. Concept of a type, you're already using them, you're already using the concept. I'm just naming it a type. A duck is a duck. Local documentation, right? So if I am in any class that uses this way of writing Ruby, I can just scroll to the top and I know what everything is. Like it just tells me. And if I'm using Ruby LSP and I see like it has an array of users, I can just command click on user and I jump to that class, right? I don't have to be like, oh, what is a user in this case? Is it because it could be JSON, it could be anything. Local documentation also is better for LLMs, right? Even if you have like an agentic LLM tool that's able to go and look up other files, it's not going to be able to look up all your files and find all of the different places where you've kind of defined what this class is meant to do, which are outside of the class, right? We want the conventions to be owned by the class and enforced by the class and visible from the same file that class is defined in, not defined in all of your code all over the place. Or at least that's what I want. And LLMs do a really good job when they're able to have that context immediately. We get to make invalid states impossible to some extent. I should put a star here. Like, it is not a 100% type-safe system. It's not even TypeScript level, but adding these validations at the boundaries of objects gets you so far in terms of like, you run your tests, and if there's something wrong, they're going to pick it up straight away. I didn't add this, but actually like great error messages I would consider to be a feature. So our types are very careful how they generate error messages. So if you have a type that's like array of string, and you give it an array, but like the third item is wrong, it won't just tell you that the whole thing was wrong, it will tell you the third item was this, we expected it to be one of these, and the errors are really nice. And the great thing about doing it at runtime is it's always compatible with existing code. You can use this and get value from it in 5 minutes. And you can keep using metaprogramming, which for me is what makes Ruby so great. Like, I can move so fast in Ruby compared to TypeScript when I'm building certain kinds of things. I wouldn't give that up to have static typing. I already said your existing tests are more useful, but even if something gets past development, gets past your tests, it makes it into production, and some crazy bug in Puma and Rails means that one user is treated as a different user, and so they don't have email addresses, and they end up nil. You're not going to end up deleting 4,000 emails from Zendesk. So I would say that Ruby has literally always had types. It's just that we've been thinking about types in a too narrow a sense, like as being like static types. Ruby has runtime types, and it has a great interface for working with them and for building them. And that is the end of my talk. I think I got it in 45. Let me just...
All right, any questions? Really?
Hi, thank you for the talk. Very nice presentation. Could you tell me the difference between literal fun and dry types, for example?
Yeah. Literal uses the triple equals interface, where dry doesn't. So dry types are like a specific thing. They also cover more than type checking. Like a dry type can actually knows how it can be coerced and what its default value is. And for me, that's like the wrong place to put that information. For me, that belongs with the property, the idea of a property. And the type should be focused entirely on, basically, it has two functions. One is determining whether an object is described by it. And then the other one, which is optional, is determining whether another type is a subtype of it. So it's just like being able to do that means that you can use like all of the objects in Ruby. They're already types. Like I can just use a string as a type or the class string as a type. I don't need to have this extra thing.
Any other questions?
Thank you for the presentation. I have a question. This literal data, does it throw an error when you pass the wrong prop?
Yes, I should have said that. Yes, that's literally what it does.
Yeah, and so in production it's the same, yeah? So you have just the exception and you have to deal with it.
Yeah, so we, when I originally built this gem, I made it with the ability to disable type checking. So you could run it in production, you could turn type checking off. And the reason I did that initially was like, I thought it was going to be a performance issue. But I ran it in production with type checking on, and it was unnoticeable. And actually, what you don't want to do in production, even though it kind of seems unintuitive, is just keep going when something is wrong. Because it's better to raise an error than to like keep deleting 4,000 emails. So what I found is it means that you're more likely to have errors like surface quickly, but then you can deal with them quickly. You've got an error that tells you exactly what went wrong. It tells you like what it got, what it should have been, and you can fix that. And actually, like when we deployed this at ClearScope, our production error rate went way down because we were just like running this locally, running it in our test environments, just brought it way down. So even though there are more opportunities for it to raise, it didn't raise more in production.
Thank you.
Hi, thank you for the talk. I just like how people have the same questions as I do, but I have a third one, so.
Okay.
Yeah, when you're defining a public method, you usually want to specify the types of the attributes along with the definition. So as far as I understood, the way you will do this is by adding a pattern matching string at the first line, right?
Yeah, you could do that. Where I've explored like different interfaces that you could use at runtime to do like type checking on at the method layer, and I haven't found any that I really love. And it's at the point where you get so much value from just checking at object initialization, the object boundaries. For the most part, that works very, very well. I think, yeah, if you want to check a type on a method, you either want to have that like create an object, like if you have like a service object or something, or yeah, do your own types using the pattern matching.
Thank you. May I ask
Yeah.
another one?
Yes.
Do you think that this gem is a good fit to write a validation library? I mean, when the user passes you some parameters and you return to them the list of errors.
Yeah. I would like to, yeah, I think so. Right now it's not great for that because you just try to create it and it will raise. I think it would be useful if you could, instead of trying to create it, you could like call them at like validate instead of .new. And you could, it would like do like a soft run. So it would like check, it would check against its schema, the parameters, and then it could give you back just like an array of errors or something, rather than raising an exception, because you don't want to raise as like part of everyday code. So yeah, I think it would be a good basis, but it's not quite there yet.
So you said that Ruby people don't like types. I think what Ruby people don't like is verbose code,
Yeah.
which usually is a result of describing the types. I think in RBS you can define the types outside of your actual class, right?
You can, yeah.
Have you experimented with this idea as well?
I haven't, no. It's already the case that switching from, like if you just switch from using a standard initializer where you're taking parameters and you're assigning them to instance variables, you're already going to be writing fewer lines of code just by switching to use literal. So I don't see it as being like having like a deficit there in terms of lines of code. I personally really value being able to scroll to the top of any class and immediately see what everything is and click to jump to them and stuff like that. Yeah, I haven't explored like doing it in a separate file.
All right, the last question and the rest of them. Joel, are you joining us at the after party?
Yeah.
Okay, there will be plenty of time to discuss.
Something completely different. Do you think, because you started with the problem that it's a lot of code, like
Yeah.
twice as much to describe the types, do you think the code in production could be observed by some tooling, like let's say cover band, and that observation could be used to generate the types? So we would not write them, assume user is user, and then
Yeah.
something we'd observe that user is actually user and generate the types for you, like separately maybe.
Would this just be like part of trying to migrate to this rather than a long-term thing? Because I think the issue with that is, well, it's a few things. So one is like, let's say that it always got, like, I don't know, your size is always like small, medium, or large, right? It sees that in production, but does it know that it's a union of small, medium, or large, or will it have to assume that it's a string? Like, that would be quite difficult to figure out. Also, if it's only going to work one time. If it raises in production, if it's not the types it expected, then it's never going to have any production data to be able to inform what types they should be. So unless you're thinking of it as like a kind of picks up anomalies, like usually this is a string, but then I wouldn't want to have a system like that.
% it was something else. So
Yeah.
and then you need to review it, right? Like it would give you pull request saying you want this, and then you say no, that nil was actually not expected. Maybe
Right.
a bit too late.
I wouldn't want to have that raising errors in production personally, because sometimes you have anomalies, like it is valid for it to be this thing, but it's unusual. So I don't know if I would want that myself. I think Marco has been doing some stuff on like analyzing apps in production and then generating like documentation. That's I think would be useful. I just wouldn't want to have like that actually making exceptions raised in production on the basis of that kind of thing, personally.
More like generate the types, like RBS types.
Yeah. But like, you could do it, you could have it generate the types, but then they're not very useful if you can't exercise them. So if you had RBS types, even if you had a static type analysis tool that worked, which it wouldn't work with any metaprogramming, you would still you'd still end up in a situation where you had to go and like adjust the types as they raised issues. So I don't know if I would recommend, like, that even as a migration path. Like the migration path that I would take would be take some like simple objects, or even better still, find places where you should have had objects and you didn't extract small objects, and make new objects. And like you can use the type never, I think, that will make it always raise, like never, it basically just returns false always. And that will tell you like this attribute was wrong and I got this instead. And then it's quite easy to track down that attribute and correct it.
Right, big applause for Joel, please. Thank you.